This topic on permutations and combinations is an attempt to learn a systematic approach to counting different ordered and unordered selections. We begin with a definition of what we are trying to accomplish. If there are m ways of choosing something and n ways of choosing something else, then the combined number of selections can be found by multiplying the two ways together. This is called the multiplication principle. Let's take an example of three towns, A, B, and C, and there are 4 roads that go from A to B, and there are 3 roads that go from B to C. What we want to know is how many different ways are there to go from town A to town B to town C. Now, we could go through the top road from A to B and then through the top road from B to C. That's one way. Still taking the top road first, we could then take the second road to C. That's another. And we can finally continue on the top road, but then this time take the third road to get from B to C. That's just 3 ways, one for each road from B to C. But then I can start my counting again, but this time taking the second row from A to B and then going through the 3 roads from B to C for a total of now 6 ways. Now for each road from A to B, there are 3 ways to get from B to C for a total of 12 ways. This is much more easily counted by multiplying 4 by 3. Let's look at a more realistic problem. The old license plates were made up of 3 letters and 3 numbers. So our question is, how many different license plates can they make with this combination of letters and numbers? I have one here already. All I have to do is change one letter and I have a different selection. Now, I could keep changing the first letter and get all the possible combinations, but this goes on for a very long time, and counting them all individually will take forever. There's got to be a better way. We notice that we are choosing 6 different letters or numbers. The first selection can be made in 26 different ways because there are 26 letters of the alphabet. So can the second, and so can the third. When we get to the numbers, we notice that there are 10 different selections to be made, including the 0. So for the last 3, we get 10, 10, and 10. If we look at each selection as a town, and each number as the number of ways that we can get from one town to the next, we can see that we'll be multiplying the 26s and the 10s together using the multiplication principle. This can be written more succinctly as 26 cubed times 10 cubed. This gives us a grand total of 17,576,000 different license plates available. You may notice that those license plates are now coming in different combinations of letters and numbers. I know my license plate is made up of 2 letters, 2 numbers, and 2 letters. This allows there to be a lot more license plates available for new cars, and not to mention personalized number plates. Let's look at another example, this time looking at a selection of 6 letters from A to F, and asking ourselves in how many ways can we put those letters in a row of 3. The first thing we have to ask ourselves is ABC the same as CBA? In other words, is the order of the letters important? Because these are 2 different words or arrangements, they are not the same, and this means that the order is important. This particular concept will become important in the next couple of exercises. Once I know that, I know I'm choosing 3 letters from 6 different ones. So how many different letters can go first? Well, we've got 6 letters. So it has to be 6 different possible letters that can go first. Now how many can go second? Because we've already chosen 1, there are 5 different possible letters that can go second, which means that there are 4 different letters that can go third. Using the multiplication principle, we can see that the number of different ways of choosing 3 letters from 6 possible letters is going to be 120 different arrangements. The second part to this question asks us how many times can they be ordered in a row of 6. We say that we are choosing 6 from 6. Just like the first question, we were choosing 3 from 6. This just makes our line a little bit longer. There are 6 different letters that can go first. Once we've chosen the first, we then have 5 letters remaining, and then 4, and then 3, 2, and 1. We multiply all of these together to get an answer of 720 different arrangements. So there are 720 different ways of ordering 6 letters in a row from a possible 6 letters. This multiplication pattern that you can see going from a number and multiplying all the way down to 1, that's called a factorial and leads us to a new notation. We write the general case as an n with an exclamation mark after it, meaning start at n and multiply all the way down to 1. Let's look at the first, say, 8 of them. 1 factorial is a pretty useless result, it's just 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial goes from 4 and multiplies all the way down to 1, which is 24. Then we get 5 factorial, 6 factorial, 7 factorial, and 8f factorial. You'll notice that the answers are getting very big very quickly. What I need to do is I need to show you an example to demonstrate what's actually happening, but I want to show you it algebraically. Now, n factorial means start at your number n and then multiply by the next number down. Now, the way we write that is by multiplying it by n minus 1. That's the next number down after n. Then we multiply that by the next number after that, which is going to be n minus 2. We then continue this pattern, and we do this by showing repeating dots until we get all the way down to the end, and we're multiplying by the last two and by 1. Now, there is a button on your calculator that will do this automatically for you. Usually it has an X or an N with an exclamation mark after it. Because let's face it, if we had to do 9 factorial by pressing all 19 buttons, as opposed to just pressing 3 buttons, that is so good. Well, let's look at an example made easier by that factorial button. A group of 6 boys and 5 girls decide to see a movie. The question is, how many ways can the boys sit together? That's the first one. Well, we have 6 boys to choose from. There are 6 boys who can go first, and then 5 who can go second, 4 who can go third, 3, 2, and 1. Now, an easy way to do this on our calculator is to write 6 factorial, press 6 factorial. Now, from that list of factorials I showed you earlier, we know that it's 720. It may not be a bad idea remembering some of these factorials, but it's not necessary because your calculator will do it for you. The second question asks, in how many ways can the girls sit next to each other? Well, there are 5 girls, and that means that there are 5 different girls that can go first, 4 that can go second, 3, and then 2, and then finally the last girl sits in the last spot. This can be written shortly as 5 factorial, which gives us 120 different ways. Last question asks us, in how many ways can the whole group sit together? Now, we have 11 kids. That means 11 times 10 times 9 times 8 times 7. It's too long to write, so we just write 11 factorial. There are 39,916,800 different ways to order those group of kids. What I need you to notice is that 11 factorial is not the same as just adding 6 factorial and 5 factorial. I know 6 plus 5 is 11, but if you add the 6 factorial and the 5 factorial together, you do not get 39 million. That's an important part, an important concept. I can't stress enough how important it is to read the question carefully. Work out how many selections you're choosing from, and then how many of those need to be ordered in a row. Good luck.